All right, guys, welcome back to Algebra 2, Section 6.3, Data Analysis and Statistics. In this video, we're just going through some even examples, and hopefully it'll give you an idea of what's expected of you. Although you could calculate your own standard deviation for your data, we're just analyzing data that's already computed for us, calculated for us. So that being said, some things you're going to have to know. If it talks about between, we're looking for probability between two different values, something happening, all right? If the problem reads at least, then we're looking for numbers, that number or numbers greater than that value. If it says at most, you're looking at that number and comparing it and any number less than. So at most means less, at least means greater or more than. All right, example number 12. I've drawn a distribution curve to go along with 12. It is not necessary, although I thought it was very helpful. On number 12 for that set of problems, 11 through 16, you're given an average or a mean of 33, and you're given the same consistent standard deviation of 4. So I've gone through and calculated the standard deviations for us. 33 plus 4 is 37, so that's one standard deviation away from the average. Two standard deviations away from the average would be 33 plus 4 more, which is 41. Three standard deviations away would be 45. If we go backwards, one standard deviation going lower would be 29, and you can calculate the others. All right, exercise number 12 says we're looking at the probability that a randomly selected x value falls within the given interval. And number 12 says between the values 33 and 45. We're no longer talking ACT, it's just a score, okay? Score for anything. So, between 33 and 45. 33, 45, what is the probability? So that's the area under the curve, or these percentages that I've given you earlier. So one standard deviation is 34, 2 is 13.5, and at 45, that's the third standard deviation away. So you take these three values, you sum them, it is 49.85%. This reads the probability of X is 0.4985, and that's how it's going to be answered in the back of the text for you as you're looking at odd numbered answers in the back. All right, I did two more exercises for you. This is changing the topic a little bit. You're given in number 20, you're given an average of 64 and a standard deviation of 7, and so you're looking for the probability that X is less than or equal to 80. So it's above the average. How much is everything at 80 or below? So it's going to be, a relatively large amount, if you will. This time, you're going to have to calculate the z-score. This is the formula for calculating the z-score. You're taking your raw score and subtracting from it your mean or your average. Then you're dividing by the standard deviation. So for us, we're going to take a raw score of 80. We're going to subtract the standard deviation in this particular sample set, 64. Once you subtract, then once you've done the difference, then do the quotient with 7 below. And you get a positive, and positive is going to be important, 2.2857. Go out 4 decimal places. Your calculator is going to do a total of 10 digits, I believe. Now note, this is going to be higher than the average because 80 is higher than 64, which is why it comes out positive, by the way. All right. At the top of page 401, you have a standard normal table. Now these z-scores, just for a little background, z-scores let you compare raw scores from different tests. So say John makes 15 out of 18 on his vocabulary test, and say that Mary makes 9 out of 10 on her reading quiz. We could compare those two scores, those two test scores or quiz scores, whatever they are, from different tests, using this z-score. So that's part of its importance. So anyway, as you find that you found your quotient being 2.2857, you're going to go to top of page 401, standard normal. This z-score, this is the value on the left-hand side of the decimal, so we're going to come down to 2. And then we're going to look for 0.2857, but you're going to have to round off. It rounds up or to 3, so this is a 2.3, gives you a 9893 or 98.93% probability that the scores, with an average of 64 and a standard deviation, the scores less than 80 will be 98% of those test scores. So almost 99, or almost all of them. All right, example number 24, it reads a little differently. Same mean, same standard deviation, but it says what's the probability that these values are going to be greater than 59? So you got to find your z-score first. It's 59 minus 64, which we realize is going to yield us a negative value, divided by 7 is a negative 0.7143. So you're going to go in the z column, okay, to a negative 0, which is here, not positive 0, but negative 0, and then it's going to round to 0.7. So when you go over to 0.7, you get a 0.2420. Well, that's the values below 59. Okay, that's the values below 59. It's asking for the values above 59. So you're going to have to take all the area under the curve, which is 1, subtract the 0.2420 and get 0.78758 or 75.8%. So the values less than 64, or excuse me, greater than 59 is going to be 75.8%. The values that you're not asked for, or less than 59, would have only been 24%. So I hope you found that interesting. Again, Mr. Breeding's going to teach a statistics class your senior year, and I suggest any of you that are interested in graduate education or postgraduate degree, master's or doctorate, take that statistics class, and it will definitely prepare you for higher education. All right, hope you enjoyed.